Today, I'm going to be talking about securing AWS. So about a year ago, I did a webcast on getting started pen testing Azure. So that particular webcast was very much heavy on the O365 side and kind of a little bit more on the initial access. Today, what I really want to focus on is, first off, obviously AWS. But secondly, I wanted to talk more about what lateral movement looks like in the cloud. And I think that, throughout today's webcast, you should get at least a decent picture of how does initial access look and how does, after an attacker gets credentials, what can they do with those? And what does that look like? And what are some potential things you can look for in organizations if you're a pen tester or if you're looking for them in your own environment as well? So quick note about me. My name is Beau. I am a pen tester, red teamer here at Black Hills. I've been here for about 8.5 years now. I also wrote a cloud hacking training course called Breaching the Cloud that I teach. So that one, I have a live run of that class coming up in December. You can sign up through that through Anti-Siphon if you enjoy this cloud talk. A lot of the stuff that I'm going to talk about today comes honestly from that class. So if you enjoy this webcast, you might like the class. I have also, done a number of different talks. I just recently started doing more YouTube videos again. So years ago, I used to do a show called Tradecraft Security Weekly, where I would do these like 10-minute videos for basically any sort of tradecraft topic around security, hacking, and I kind of fell off the bandwagon on those a bit, and I just recently started doing similar type videos again. So that's on YouTube. But yeah, that's me basically. All right, so let's talk about roadmap. What are we going to talk about today? I actually have quite a bit to talk about, and I'm going to try to get through it all. I think the Azure webcast I did, I ended up going over quite a bit. So hopefully I can condense this enough into this hour this time. I think I timed it correctly. All right, so roadmap wise. First off, we're going to do a quick intro into AWS and authentication. Talk about how our IAM users authenticating, what mechanisms are they using? And then we're going to do a very short section on common initial access methods. Again, I want the focus of today being more post-compromise. I want to talk about, all right, so we have credentials. What could an attacker do with those? So I'll talk about some common initial access methods, and then we'll move on to this post-compromise recon section where I'm going to give you a quick demo into what is the AWS CLI? So how do you run command line commands from a console to the AWS environment to enumerate various resources, to enumerate roles for users, and kind of help you determine an attack path potentially. Then we're going to move on to privilege escalation and what can we do in terms of escalating privileges in an environment, specifically cloud environments. We'll talk about some common privilege escalation techniques and lateral movement techniques specific to cloud. And then we'll do a quick scanning tools section. So I'll talk about some of the ways that we can help automate a lot of our scanning. And then finally, I'm going to try to do a live demo at the end of this, where I'm going to do a multi-resource pivot. So this is going to be something that hopefully helps connect all the pieces throughout today to help show what would happen if an attacker got access to a set of credentials, and how would that look in a lateral movement scenario across multiple different types of resources in the cloud. All right, so first up, so Amazon Web Services. Why are we talking about this today? Like I said, I did an entire webcast on Azure previously. This one, I wanted to focus on AWS. And the big difference in my own point of view is generally we see a lot of Azure environments really focus heavily on the SaaS side. So focus on things like productivity software, Outlook, the email side, SharePoint, that kind of thing. On AWS, we typically see a lot of infrastructure. And it is by far one of the most, have the most popular pieces of software for cloud-based infrastructure. So think things like virtual machines, storage, networking, databases, has a ton of different services. And there's an interesting kind of view when it comes to looking at how can these resources be exploited and how are they unique in terms of what information can you gather from them as opposed to like a general, old school on-prem virtual machine? What are the differences? So many of the security features are baked in as well. All right, so I'm going to give you a quick high-level overview of what does authentication look like in AWS. So first off, there's generally two primary methods for setting up authentication for a user. There's programmatic access, and then you have your standard AWS Management Console access. So the difference between these two is GUI access for the most part. So graphic user interface. So on the AWS Management Console side, that's the way you would imagine logging into a web portal and being able to manage resources. On the programmatic access side, we're talking about submitting requests to an API. So when you generate a programmatic set of access keys, you get an access key ID and a secret access key. And so what these allow you to do is effectively run commands from either an API perspective or the command line tools that allow you to interact with resources within your AWS account. And this is commonly what we find on penetration tests. These are commonly the credentials we're looking for in most cases, and the ones that we oftentimes stumble upon. And when we look at the picture on the screen here, you can see that we have an access key ID and a secret access key. Now, this specific set of access keys is what is known as a temporary set of security credentials. And the reason I know that is because the first four letters start with ASIA. And in general, long-term access keys will start with AKIA. So I'll talk about what the difference is between long-term and temporary momentarily, and that'll come into play and be very important later on in the demo as well. But for now, just know that there are ways that you can generate temporary sets of credentials, similar to the way that you would have like a session token mechanism for like an application. So the management console, this is what it looks like. So if you were to log in to the web portal, you can be presented with an interface that allows you to manage resources. This is something that if we're trying to phish for credentials, this might be what we end up looking at as an attacker. So if we're, let's say we're targeting an AWS admin and we submit a phishing campaign to them that targets their credentials, and we have, we are successful in phishing their credentials, potentially we could log into this management console and be operating from here as opposed to command line. All right, so initial access. Again, like I'm gonna make this somewhat short and sweet. On the initial access side, because I don't want to focus too much on just the initial access today. I really want to focus heavily on the post-compromise. Also, by the way, all the pictures you see, I would say 95% of them are AI art generated with Midjourney. I have kind of like this new addiction to creating AI art for slides. So when it comes to initial access, there's a few common techniques for getting initial access into a cloud environment. And these are four that I'm going to run through in the next few slides here. So first off, public accessibility of resources. So having something exposed externally that shouldn't be, leaking secrets in code repositories. This is something that happens pretty common, actually, something that still comes up on occasion. And phishing for creds. So like I mentioned with the concept of phishing, sending a phishing email to get credentials from an admin or somebody who is using the application or using AWS. And then resource exploitation. So what can we do in terms of actually exploiting resources within a cloud environment as well? So first up, public accessibility of resources. The thing about cloud environments is that it's very easy to configure them to be publicly exposed. In traditional internal networks, you don't typically have to worry about every web application you create or every file share you create having to worry about making it publicly accessible to the entire world. When it comes to cloud environments, though, you can easily deploy an S3 bucket, so a storage resource within AWS, and configure it to be publicly exposed. And a lot of the resources within AWS are the same way, where it's very easy to misconfigure them to be public. So what happens is an organization will accidentally leak secrets occasionally by either A, they didn't mean to make it public, or B, they made it public but then forgot it was public and then put something sensitive in it. And then another example would be an insecure web app or function exposed externally. So we're talking about like Lambda functions. One of the pieces of the demo I'm going to show later on involves an insecure web app that's being publicly exposed. Database services with weak creds. It's literally a checkbox to make most databases public to the internet from an AWS environment. So why would this matter? This can lead to compromise of things like sensitive data that are in the buckets, potentially credentials that maybe have been put in a config file that's out in a bucket, additional access keys. And, in the case of vulnerable services, potentially underlying server infrastructure as well. Secrets in code repositories. This is something that we see come up pretty often still. And it's surprising because a lot of the larger repository softwares like GitHub, they actually have functionalities now that look for secrets. That if I were to go try to post a piece of code to AWS today, there's actually some checks that happen to look for that, to look for common secrets, things like AKIA for an access key, right? However, even with those checks in place, we still see these come up where a developer will go to publish a piece of code and they will have hard coded in a set of credentials into that piece of code, and they'll make it public, right? Like they'll actually publish it to a public GitHub repo, and now those credentials are just exposed externally. And what's interesting about code repositories is they have commit histories in most cases, right? So anytime you go to update that piece of code, you are not only creating a new instance of that code, but the entire history of what was there before it is still there. So in the case where, let's say, a user published a password to a Git repo, that password will live there. They could go and overwrite it with another commit, but if they didn't go and actually scrub that commit history, then that password might still be there in the commit history. So, this is one of the things we look for as well. When it comes to phishing, standard phishing techniques apply here. This is an example I saw the other day. It's an Amazon specific phish, right? That says, "Hey, your service is about to be canceled." And or it's about to be, it has now been suspended, and you can go pay at this payment page. So if you've ever had an AWS account, you know that like you get billed for like even the tiniest little things, right? Spinning up an instance for just a few minutes, or having any sort of storage bucket out there, like it generates costs pretty quickly if you don't put anything down. So it's common to get emails from Amazon saying, "Hey, you've been charged X amount." So this is one of the phishes that I think is pretty sneaky on this front, because it's kind of playing off that idea of, hey, you didn't pay your bill and now your service is going to be suspended. So the idea here would be, though, to phish for credentials, right? So this could be not necessarily looking for programmatic access, but maybe access to that management console. And so this would be a case where maybe we spun up something like an evil Gen-X, like reverse proxy situation to try to get access to credentials. Resource exploitation. So just like traditional networks, you have the ability to spin up resources like virtual machines, databases, web apps that can be exposed publicly within your own cloud environments. Now, these resources, these pieces of software, are still vulnerable to the same, attacks and same exploits that end up coming out for normal pieces of software, right? So anytime that you have an unpatched vulnerability, anytime that something new comes out, these are things that we need to look for as well from an external context, right? Same thing applies to traditional web app vulnerabilities. It's things like having weak authentication, being able to brute force credentials, being able to inject commands, so like SQL injection, command injection type vulnerabilities. And one vulnerability that I find actually very specific, that is in my eyes not something that you typically tend to find all that interesting in most web app cases, tends to be extremely interesting on cloud environments, is server-side request forgery. Server-side request forgery is the ability to cause a web server to send a request on your behalf. So basically, the idea is that you find a vulnerability that causes the web server to be able to submit a web request for you. And that will be important when we come up to our metadata section later on, because there's a specific web URL that only that server can hit itself. And I'll show you that in just a bit. After exploiting a resource, though, what do we look for? So we need to start talking about what can we do from a post-compromise recon perspective. What can we do after we've compromised a set of credentials? Now, like I said, like the initial access section, that's honestly like an entire day of my class. So it's very condensed, but post-compromise is really what we want to focus on today. So we're going to talk about what do we have access to? What roles do we have? Things like, is MFA enabled? So if we had phished a credential, are we going to need to worry about MFA? What can we access? This is actually probably the biggest piece of this, right? So when you start looking at recon from a post-compromise perspective in any environment, it comes down to, well, what can you get access to? Can you access these virtual machines over here? Can you access these storage buckets over here? Who are the admins? And then ultimately, how are we going to escalate privileges? And one of the kind of interesting things about API level access to cloud environments is you can generally see configurations around security products. So you can query things like, is CloudTrail enabled for this region? So that would be like the logging functionality, right? And that's one of the bigger differences. Think like if you were to get access to an endpoint, right? You could open up like Task Manager and see like, hey, this AD or this EDR is enabled. Same thing, but in the cloud context, we can query APIs to determine what security protections are there as well. All right, so when it comes to AWS permissions, there are various types of AWS accounts, first of all. So you have a root account, you can have IAM accounts that are created underneath the root account, and then you can have temporary security credentials that can all have policies and permissions applied to them. Now, the root account is basically the account that when you signed up for that AWS account, it's the main, like, highest level account that has all the privileges in the world to do anything it wants. Now, underneath that account, you can start to create what are known as IAM users. And as IAM users, you can start to set permissions for. So in AWS, permissions are typically set with three different pieces. So you have an effect, you have an action, and a resource. There's a few examples here on the right, and I'll kind of walk through what these mean. But in general, the effect is an allow or deny rule. So you're basically saying, are we going to allow this or are we going to deny this? The action is a set of specific parameters. So for example, you could say, I want to allow the action of S3 anything. Like you could write to an S3 bucket, you could create an S3 bucket, you could get items from an S3 bucket. So you can actually include wildcards like this. So S3 : star. Or you can be very specific about it. So you could give an action of something like IAM : create user, where you're basically saying that you can leverage the IAM resource to create users, but that's it. And then on the last piece, resource. So you can actually filter it down to what specific resource you actually want to apply the policy to. So in this case, we're applying it to just an S3 bucket. So you can say, we're going to allow get privileges on this one specific S3 bucket. Now, in general, this is kind of how these policies look. When you start looking at policies, you'll see something like action star, effect allow, resource star. And so that would be like an administrative policy, because you're basically saying, I'm allowing all actions because there's the wildcard there, and on resource star. So literally that'd be like an administrative policy saying it has full access to everything. Now, temporary security credentials are kind of interesting, and we'll talk about those in just a bit when we get to a section where we're going to talk about assumed role policies. But in general, they're short-term permissions that you can request for certain purposes. So one thing I really want to highlight here is the ability to apply policies to identities and resources. So if you were to get access to let's say a user account on an internal Active Directory domain, you might be familiar with the concept of being able to query your groups from the domain, right? You can say, hey, what groups am I in? And that will tell you what your specific user is a part of, right? But just like on an internal domain, a file share can have a permission that says, hey, that user, the domain user has permissions on the file share. It's not something you would query necessarily on your user object from the domain, but it's something that you could query if you ask that specific system. So same thing, but in the cloud context, you can create identity-based policies that are applied to users, and you can create policies that are applied directly to resources. So think things like an S3 bucket. So you could apply a policy directly to an S3 bucket that says user X over here has access to it. Now, unless you enumerate manually or automated and go and try to access that S3 bucket, you might not realize you have access to that S3 bucket. So like on the right here, there's a good example kind of showing identity-based policies versus resource-based policies. So take a look at Zheng Wei down here at the bottom, right? So Zheng Wei has no identity policy applied to them at all, right? So if you were to query that user's access, it would look like they literally can't do anything. Now, if you look at the resource-based policies on the right, you can see that resource Z here has Zheng Wei allowed full access. So that user would be able to have full access on whatever resource that is by accessing it directly. So this is why it becomes important to not only look at what roles you have, but also start to analyze resources and what roles are applied to other resources. All right, so how do we start to query this stuff? How do we start to, gain a little bit of information about these resources and about our access? Well, the AWS CLI is pretty much the go-to tool for this. So on the topic of being able to connect to the API, there's a few different ways you can do it. First off, the AWS CLI is one. There is a great Python library called Beau 3, which is also a good way to do it. But in our case, I'm going to just give you kind of a high level, I guess, like crash course on AWS CLI here. So it's a multi-platform tool, first of all. And if you had a set of credentials, programmatic access keys, that is, you can set up a profile on your system with the AWS configure command. And when you run AWS configure, it'll walk you through the process of adding in your access key as well as your secret. And then you can set default regions if you want. Now, one of the things that's kind of interesting about AWS is that there are certain regions that you might have to query for certain resources. So things like EC2 tend to have resources spun up in specific regions. So after you configure a set of access keys, then you would be able to leverage the AWS CLI. Now, one of the things that I think is really awesome about the AWS CLI is that you can create profiles. So you can not only have your default profile, but let's say that you're on a pen test and you've got 10 sets of creds. Instead of just overriding the same default profile, you can specify specific profiles with -- profile. So you can say AWS configure -- profile creds I got from a Git repo, and you could call it that, right? And then now, whenever you go to query the AWS CLI, you can specify that profile for each command you would run. So this is kind of so. If you've ever been caught on a pen test where you ran local like binaries, things like the net command, ipconfig, who am I tends to be another one of those that get caught on a lot of engagements. This would honestly be one to watch out for if you're a defender, I think, in a lot of cases. It gets called a lot, though, so it's probably not something that is going to be the easiest thing to identify. However, the AWS STS get -collar -identity command is effectively the who am I of AWS CLI. Let's say you got a set of access keys, right? So you have your AKIA access key, you have the secret access key, right? That tells you nothing about that user. Like there's no username that says like, hey, this is an admin, or hey, this is backup user, or hey, this is dev account 1 or something like that, right? Like there's no identifiable information there. It's just a long string of letters and numbers. So how do you get at least a little bit of an idea about what that user is for? You can run the AWS STS get -collar -identity command, and you will get the actual username for that IAM user that was specified in the console whenever they created that user. But again, that's like some EDRs now, like literally running the who am I command will get you burned. So how does the AWS CLI break up commands? First off, when you run the AWS command itself, the first section immediately following AWS is the service you want to interact with. So in the picture I made here, we've got EC2. So if you wanted to interact with EC2, you'd say AWS EC2, and then you would complete whatever commands you wanted to send to the EC2 service. Now, let's say you wanted to operate with IAM, you would put IAM here. If you want to operate with S3, you would put S3 here. So this is basically where you'd specify the service. The next section is the action. So we want to describe - instances. That is the AWS command for listing out EC2 instances and any information we can identify there as well. So things like IP, things like DNS names, things like network configuration information, that kind of thing. And then finally, region selection. Now, like I said, some AWS services require that you leverage a region as well. And that's just because of the nature of how AWS spins up resources in certain regions. But things like S3 buckets, you can run AWS S3 LS, and that should list out all S3 buckets globally for that account. When it comes to listing out IAM users, you could run AWS IAM list -users, list -roles to list out those roles that we talked about that we might want to identify whether or not we're a part of. We might want to identify if we're part of a group, because not only can you directly apply roles and policies to a user, you can apply them to groups as well. And that actually comes into play when we start to look at assumed role policies later on for privilege escalation. When we start to look at like public resources, now to start, this is something that honestly should be done externally to start with in most cases. Like in most cases, you want to be able to attempt to identify any sort of public resources externally. Now, the way that this is done is via predictable domains. So if you go to create an S3 bucket on an Amazon account, you create a custom name for that S3 bucket, but it gets prepended to an actually predictable URL. So it gets prepended to s3.amazonaws.com. So it makes it a brute forceable moment where we can brute force names of S3 buckets themselves. So this is something that, it's hit or miss though, because like I could go spin up a bucket that's called FBI Surveillance Van 1 if that one's not taken, right? And, same thing for like, your Googles and Twitters and whatever else, right? If those buckets had not previously been generated, you can go create them. Now, so this becomes a problem of attribution to an actual organization. So what I would recommend doing is running a tool like Cloudinome. So the tool I've listed here on the screen, one of my favorite tools for identifying public resources. Like this is, if I were to go on an assessment for a red team engagement or a cloud assessment or an external today, this is probably the first tool I'm going to run because this is a great way to help identify any public resources that may be out there that you could brute force, potentially, the names for anyway. And you'll get something kind of like what's on the right here. So in this example, Cloudinome found an S3 bucket called Glitch Cloud, which is it's one I set up for this. And it immediately listed out the files within it. Now, if I was testing company Glitch Cloud, I would have to say, hey, is this actually yours or not? Or is this, something that somebody else set up? Because, you have to at least make sure that you are attacking the correct organization here. Because again, anybody can spin these names up. Now, this is something that I think is very, very important. When it comes to public resources, when you're external and you're trying to identify these public resources from an external context, there is a high likelihood that you're not going to find everything in most cases, unless they are very specific about the bucket names, right? Like they just name it the company name. There's a likelihood there that you're not going to find everything. So I always, after getting credentials, after doing any sort of authentication to an organization's environment, try to enumerate all public resources. And not only S3 buckets, but things like public IPs for EC2 instances, load balancers. And I ended up putting together a few scripts to help with this. So I have a repo on GitHub called Cloud Pentest Cheat Sheets that I've been trying to keep updated with a lot of the stuff that I use on Pentest, on Cloud Pentest. And I just recently added in a few loops, a few while loops here to go through and dump things like all public IP addresses for EC2 instances, to dump all Elastic Load Balancer DNS addresses, to dump all RDS DNS addresses. And the reason is because after getting access, you now have the ability to see, okay, well, I didn't brute force this S3 bucket. And the reason is because it's got a really long, complicated name. It's not something that was easily just brute forceable, right? Externally, but nevertheless, it's public. And I've had cases where I will be assessing a company after getting credentials, find that there's a public bucket, a public storage bucket, go look at the storage bucket, and it's got a ton of sensitive stuff in it. Or go find an Elastic Load Balancer web address and find that it's running like an old version of PHP or something, right? So additional vulnerabilities that can come from just identifying those public resources and then trying to look at them externally. Privilege escalation. So now, what are we going to leverage here after authenticating to actually gain privileges or permissions that we previously didn't have? Is there a way for us to take what we learned from the previous commands by enumerating resources, enumerating roles, to either A, get access to additional credentials, or B, find vulnerabilities in services? Maybe some of those services externally exposed. We can go and exploit to some extent. So let's walk through a few methods, potential privilege escalation methods here. All right, so first up, instance metadata services. This is one of my favorite things to talk about when it comes to anything cloud related, because this is something that I find honestly kind of fascinating about cloud environments, is that instance metadata services are they're ways for cloud systems to orient themselves in the cloud. So let's say you're deploying like 10,000 virtual machines within a cloud. You can specify certain pieces of metadata that can be applied to every single one of them. And what the metadata service is literally a web. It's a web app of sorts that gets spun up on the non-routable IP address of 169.254.169.254 on every single cloud virtual machine. So that's something like the first time I saw it, I was like, wait, there's a web service running on this virtual machine. Like, you can't access it. You're not supposed to be able to access it externally. However, due to certain vulnerabilities like SSRF, you might be able to send requests to it externally. So they should only be reachable from the local host. However, things like server compromise and certain vulnerabilities like SSRF might allow remote attackers to get it. So why is that important? Well, first off, let's say that you had an application and you had an EC2 instance, right? So a virtual machine that you wanted to authenticate to an S3 bucket, or you wanted to have the permissions to retrieve something from that S3 bucket. So one of the ways could be you hard code credentials, right, into the VM. Likely not the best solution there. One of the ways that Amazon allows you to kind of solve this problem is through role policies. So you can specify a role policy and you can assign it to a virtual machine. And you can say, hey, this virtual machine, if it requests this role policy, we're going to give them temporary security credentials that allow them to do X. So you're not hard coding credentials necessarily at that point. However, by being able to query that role policy service on the metadata service, it can allow you to actually gain access to those temporary sets of credentials. So first off, this is pretty much where it lives on the AWS metadata service. So it's at /latest/meta-data/IAM/security credentials, and then whatever that role name is. Now, this is literally like a directory indexed service as well. So whenever you start to dive through this, I'll show you in a minute in the demo. You can poke around quite a bit. But once you navigate to this URL directly, if a role policy is applied to it, it will spit out a set of temporary security credentials for you. Now, that set of temporary security credentials can technically can have more permissions than what you currently have as that instance. So this could be a potential privilege escalation here. This might also be something you could hit potentially externally via a vulnerable proxy as well. So if there's a proxy service like Nginx running on an EC2 instance that's misconfigured to allow connections to that metadata service, you might be able to actually proxy a request directly through it to itself to hit that metadata service as well. This is what happened in the Capital One hack as well. So an attacker exploited SSRF on EC2, and they accessed the metadata service that allowed them to get that temporary set of credentials. That temporary set of credentials allowed them to authenticate directly to AWS to hit an S3 bucket that was private. It was something that was not publicly exposed, but due to having the ability to query that metadata service, it gave them the creds they needed to access a private S3 bucket that had a ton of sensitive data. Yeah, I saw a mention of IMDS v2 in the chat. Yeah, so like I think a couple years ago now at this point, AWS created what is known as the IMDS version 2. And it's a way to mitigate a lot of the remote access to the metadata service via things like SSRF, via the proxy. However, IMDS v1 is still like the one that's enabled by default in most cases. But it is something that even if you did get remote server compromise, IMDS v2 isn't going to prevent you from accessing the metadata service. So another thing that we tend to find credentials, and this could be another privilege escalation opportunity, is through user data and environment variables tied to various services. So a lot of times we'll see things like Lambda functions get deployed with environment variables that contain secrets. So kind of what it looks like what's in this screenshot here. So this is a Lambda function where a set of credentials is literally being passed to that Lambda function via environment variables. So that when that Lambda function executes, it has those credentials available to it so it could do something. Now, the thing is with the AWS API and using the CLI, we can query the configurations around Lambda functions. And oftentimes we find things like this. Same thing on EC2 instances with user data. I was just on an engagement recently where there was an SSH key, like in clear text, like the actual full SSH key in user data. Assume role policies. All right. So I mentioned it briefly a minute ago about temporary security credentials. And this is where assume role policies kind of come into play. There's ways to create trust relationships between users that you want to provide access to a specific service without actually granting them it directly. So similar to the way you would apply a role to like an EC2 instance and say, hey, I'm not going to hard code creds for you, but you can request this role policy and get temporary creds. Same thing, but for users and IAM users. So let's say that I wanted to provide access to somebody who wasn't working at my company, access to a specific resource. They can give me their account resource number, which is the ARN, from their own Amazon account, and I can apply an assume role policy to their account. And effectively what that does is it allows them to call what is known as the security token service assume role resource. And whenever you call that, if they have the permissions that I've specified in my own assume role policy, then they can request temporary security credentials that give them the ability to go and access whatever I specified for them. So in the example here, there's two separate accounts. So you have the account on the left is the one that is providing access to their own DynamoDB resource. Account on the right has a user called Joe, who is, or sorry, it's backwards. So Joe's on the left, account's on the right. So on the left, we've got Joe who wants to authenticate to the DynamoDB. However, instead of me applying direct policy to that user to say, hey, you have access to this DynamoDB, I give them an assume role policy that they authenticate using their keys. They request temporary security credentials. I give them this set of temporary security credentials. They can now leverage that temporary set of security credentials to authenticate to DynamoDB. And they're short-lived, typically like an hour. This becomes kind of interesting because if, let's say, an assume role policy was applied within a group, within an actual Amazon account, and you enumerated policies tied to that group, and they have overly they have created overly permissive permissions for that group through an assume role policy. I might be able to, as my own user, assume that role policy and get a new set of permissions that I previously didn't have. So let's talk a little bit about leveraging scanning tools to help us kind of identify some of this stuff too, because so far we talked about CLI a little bit, but on the automation side, what can we do that can help us? So first off, depending on if you're trying to be evasive or not is kind of where you have to draw the line if you want to start automating things. So I would say in most cases where we're not trying to be evasive, we will start running scanning tools to identify as much as we can quickly. So first off, I would recommend at least starting with manual inspection. So using single commands one at a time. But if you really want to quickly assess cloud environments, there are a number of scanning tools that allow us to help to find things like IAM permission issues, to find public accessibility resources, things like VM instance storage encryption. That's one that comes up pretty often. Network and egress rules, and then virtual machine metadata. So there's a couple tools here. I'm going to kind of walk through. Pacu is a tool from Rhino Security Labs. Great tool for quickly identifying privilege escalation vulnerabilities. There's a scanner, privilege escalation scanner, that will attempt to identify a number of common vulnerabilities. There's EC2 enumeration, I already said that, persistence modules and exploitation modules as well. ScoutSuite is another one that I tend to use pretty often and find it super useful for identifying a lot of best practice issues around cloud environments. So ScoutSuite by NCC Group, it's a multi-cloud auditing tool, supports AWS, Azure, GCP, Alibaba Cloud, Oracle as well. And this is, if I had to say, like, if I had to compare it to like something like a Nessa scanner, it's probably the closest-ish thing to a vulnerability scanner of sorts for cloud environments. However, I will say that it's more on the best practice configuration side than it is like actual vulnerabilities. So it's a good tool to run though, to get at least that high level best practice look into a cloud environment. WeirdAAL by Chris Gates. I love this tool. And so this is more of an enumeration tool than a vulnerability discovery tool. So if we go back to one of the slides that I talked about before in regards to identity-based permissions versus resource-based policies, right? You know, if I'm just looking at my own permissions with the various commands I could run to enumerate my own permissions, I'm going to miss out on a lot of the stuff where resources have actually had certain permissions applied to them. And so the thing I love about this tool is it will go through one by one through each service and attempt to run various commands to enumerate what permissions you have. So even if you don't have full read access, you might still get some interesting data just by running WeirdAAL. And I'll show you it here in a second as well. All right, so we're up to a demo. And I'm going to do this live, so we're going to see how this goes. Hopefully, sacrifice enough chickens. I did have a chicken sandwich, so like I think that counts. So I think it counts. All right, so we're gonna pretend here that we've got an AWS config. We're gonna start here with this idea of us compromising a set of credentials through a code repository. Right now, what I'm going to walk through here. So what I'm going to walk through here is basically a demonstration of a tool called CloudGoat. So I have a link to that in I think the next slide after this. But so CloudGoat is awesome. So CloudGoat is it's a tool that's written to help leverage Terraform to spin up resources within your account. So it's a way to generate vulnerable infrastructure within your own environments. So we're going to walk through one of those scenarios from CloudGoat. All right. So first off, the cool thing about CloudGoat is once you've spun it up, it will spit out a set of keys for you, and then it's kind of up to you to figure out like what to do from there. So it becomes kind of like a CTF of sorts. All right, so first off, we're going to pretend that we were assessing some code at an organization. We stumbled across an AWS config file. And sure enough, in this AWS config file, we've got an AKIA access key, and we've got a secret access key. So it's one of the first things we could do. Well, let's configure a new account. So we'll do AWS configure. And we're going to give it a profile, like I mentioned earlier. And we're just going to call this config creds. And it should ask us for the access key. And then it should ask us for the access secret access key, sorry. And I'm not going to set the default region or the format name. So now that we have this set of credentials configured, let's try them out. So remember I mentioned using AWS STS get-caller-identity. And then we'll do profile of config creds. And if it was successful, we should get something like this, where we now see the user ID tied to that. But more importantly, we get the actual name from the account. So we see user/solace, and then there's a GUID of sorts on the end here. So this is initial access, right? So we have initial access to this account. So what's one first thing we could try to do? How about we try to describe EC2 instances? Right. So AWS EC2 describe -instances --profile config creds, and we're going to give it the region of US East 1. Here, I'll get rid of this because we don't need that anymore. So what happens if we run that? We get access denied. All right. So we don't have permissions to read EC2 with this set of credentials, right? All right. Well, what about Lambda functions? Can we read Lambda functions? Because that is another one, like I said, we tend to find interesting stuff in. And sure enough, we've got read access to Lambda. So if we start to look through Lambda functions here, we might find something interesting like environment variables. Now, this is like honestly like a super real world scenario here. This is something that happens pretty often where we see environment variables tied to Lambda functions. So in the Lambda functions themselves, we've got a new set of access keys. So this is a different set of access keys than we had previously. So now this is where the lateral movement comes in, right? Like this is where like cloud pivoting comes in, is we have a new set of credentials. Let's go set those up and see what they have, right? Let's go try them out. So, and see if they have any additional permissions that we didn't previously have. So what I'm gonna do is I'm gonna copy that access key and I'm gonna configure a new account. So I'm gonna, AWS configure --profile, and we're gonna call this one Lambda creds, right? So this one is gonna be are credentials we got from the Lambda function. So now we've got it, access key ID, secret access key. Again, we can run AWS STS, get-caller-identity, give it the profile of Lambda creds, and it works. We can see that the user in this one is different. It's not Solus, it's wrex, whatever that is. All right, so if you remember with the config creds, we tried to describe EC2 instances, we got denied, right? So what happens if we run that exact same command using the Lambda creds? So if we run AWS EC2 describe -instances -- profile, and we're going to give it the Lambda creds profile this time, right? -- region US-east -1. What happens? We have the ability to read EC2 with the Lambda creds. So you can kind of see where the pivoting is coming into play, right? And yeah, and of course you're reporting as you go. Yes. Thank you, time traveling nerd herder. Yes. That is a great point to make. You gotta take those screenshots. You gotta at least make some notes here. So our first escalation here, right, is we didn't have access to EC2 with the first set of creds. We found a set of Lambda creds. We're using those Lambda creds. Now that set of Lambda creds can read EC2. Okay, so let's start to look through EC2. So we see an instance here, right? We see that there's a public IP address tied to this instance. So what happens if we open up a browser and navigate to it? Is there anything interesting running on the web, like web server there? So HTTP:// and then we'll throw in the IP, and we get an error. So let me make it a little bigger. So, this is where BB's web app hacking class comes into play. So what do you do if you start to see errors on a web server? Well, first off, we see this type error: URL must be a string, not defined. Okay, so not defined. So what if we throw URL parameter on the end of it? What happens? Okay, well, we've got a web server. It says, welcome to Seth's SSRF demo. I wanted to be useful, but I could not find blank for you. Right. So again, this is, BB hacking, web app hacking class 101 here. But we got to start poking around, right? We've got to start playing around with the URL. So, all right, so URL parameter. What if we throw https:// google.com in there? And it tries to find google.com. Sure enough, we could try some XSS probably, right? Like we could see if this thing's vulnerable to XSS real quick. So we could, throw some script tags in if I can type correctly. Let's see, alert hacked. And yeah, okay, so it's vulnerable to XSS. All right, so now what else? Now, remember what I mentioned earlier, we're really hyper-focused on cloud here, right? Like we know this is an EC2 instance. We know that we're working with a cloud-based system here. Can we hit that metadata service? This is where server-side request forgery comes into play. So http://169.254.169.254, and we get something that looks like this. Here, what I'm going to do is I'm going to show you the source because it looks a little better when you view it from page source. So we get a bit of a directory listing here, right? So this is the metadata service. All right, so this is the instance metadata service. So if we go, let's go to latest on this metadata service, and you should see a few additional directories here. So we've got dynamic, we've got meta-data, and we've got user-data. So first up, user-data, a lot of times you can find really interesting stuff in user data because that tends to be the place where custom scripts and things like settings that are being applied to that virtual machine get placed. So like you can see there's a script here, right? So a bash script. This is the place that we typically find things like SSH keys and credentials and things like that. So that's one place that you should be looking. Secondly, if we dive down into the meta-data URL, we can see that there's a number of settings here that are available to instances, right? So we can start to look at things like the AMI ID, the profile, public host name, all these things. For the sake of time, because we're already getting kind of close to the end of time here, we're just going to go straight to IAM, which is where we're going to look for a temporary set of security credentials. So if we go to IAM, we should see info and security-credentials. So if we dive into security-credentials, what's there? we see a role. Now, if you don't see something here, then that typically means that there's not a role policy applied to that specific instance. But in this case, we have a role policy. So now what happens if we navigate directly to that role policy URL? You should see something that looks like this. Let's go back to the non-source version real quick so you can see this a little better. So you should see something that looks like this. We've got an access key ID. We've got a secret access key right here. And then we've got a token, long token, right? So if you remember back to when I first started talking about programmatic access keys, I mentioned how ASIA is a temporary security credential. So that means that this is something that is short-lived. It's not something that will last a long time. However, we could just request this URL again, potentially get an updated set of temporary security credentials. So now how do you use this, right? How do you use a temporary set of security credentials? So I'm going to show you WeirdAAL real quick, because that is, like I said, one of my favorite tools when it comes to kind of enumerating information quickly in an AWS environment. So if I'm going to run Python 3 -m venv, I'm going to start a virtual environment for WeirdAAL. And then we will source WeirdAAL /bin/activate. And then finally, Python 3 create DBs. So WeirdAAL has database structure, and it stores all of the results in a database. Now, with WeirdAAL, it leverages an env file to authenticate. So if we are going to authenticate with that set of temporary security credentials, we need to copy the env.sample file over to .env and then modify .env with our credentials. So this is what a standard set of AWS credentials looks like, a file, so to speak. So you typically have an AWS access key, which is going to be our ASIA key here. And then we've got the secret access key. So we'll paste that in the AWS secret access key spot. And then finally, we need one more thing. So this is where temporary security credentials start to become kind of interesting. So with temporary security credentials, you not only need the access key ID and the secret access key, you also have to have a session token. And so we've got a session token here that's presented in this metadata service URL. And you just add an extra line for AWS session token. And then we'll paste that in. And we should be good to go from there. That should be, I've actually pasted it in correctly. There we go. All right, so we're going to paste it in, save the file. And now we should be able to use WeirdAAL to authenticate as that temporary set of security credentials. So a quick way, again, like very noisy way to enumerate everything here, as we could run Python 3 WeirdAAL.py-m recon_all-t SSRF. So we're creating a table called SSRF here. And if those credentials are valid, we should see that it starts to authenticate, and we should see it start to go to town on the various services. So what have we done here? So we first had a AWS config file, right, that we compromised via a GitHub repo, right? We added in those credentials. We authenticated. We tried to access EC2, couldn't access EC2. We accessed Lambda. Lambda had an environment variable that had a set of credentials, right? We used that environment variable credentials to authenticate as well. We saw that we could use those credentials to access EC2 instances. We found this web server EC2 instance, and we found that it's vulnerable to SSRF, leveraged SSRF to access this temporary set of credentials, and now we're authenticating more, right? And I'm not going to, let this complete, and we're not going to stay here all day and run this. But if you want to see the end of this, go do the CloudGoat demo and see where this takes you, because this is not the final step. I'll just say that. So let's go back. Let's go back to slides here. That's a demo. I mainly just kind of want to show what does a cloud pivot look like, right? Like that is effectively like how lateral movement looks a lot of times in the cloud. It's you're getting access to new sets of credentials. You're moving from resource to resource, and leveraging things like vulnerabilities like SSRF. So resource-wise, so what are some resources that you might help with this? So again, like I created these cloud pentest cheat sheets that have a lot of the standard commands that I might run on a pentest. CloudGoat, that is the tool that I was just leveraging a minute ago to generate that vulnerable environment. There's a few other vulnerable environments out there if you want to practice doing any sort of AWS-based assessment. Flaws.cloud, Flaws2.cloud, SadCloud's another good one. What are some key takeaways here? Initial access can come from many forms. So we talked about phishing. We talked about finding public resources. Talked about getting access to code or to credentials via GitHub repos, right? Secondly, attackers can leverage the AWS CLI to send API requests to interact with resources. You could see just having that set of credentials, we were able to authenticate to the API, and we were able to understand the environment purely from the API perspective. Enumerate both identity and resource-based policies, because a lot of times you won't be able, it's not going to be evident that you have access to something unless you try to access that thing. So it's very important to enumerate both. Cloud environments can present a new and interesting method for lateral movement, right? So you could see here, we pivoted from credential to credential via various resource permissions. And that's typically how cloud pivoting looks. And then finally, leverage scanning tools to help you with automating the enumeration parts and any of that extra vulnerability discovery. So that's the end. If you like to see, I teach a class on this stuff called Breaching Cloud. I also make some YouTube videos. So I've got a link there, bit.ly/Beau-YT. I would be super grateful if you guys followed me, subscribe, that kind of stuff. So thank you guys so much. Jason, I will pass it off to you, man. And I stayed under an hour.
That was the fastest hour. Like that just went by. So well done, Beau. I used to sit in on your 4-hour classes. Like the 4-hour classes go by as well. It's not like, oh man, what just happened? But do you still stay after and do lab stuff, or like how do you do your labs? Because it's all hands-on labs. So
yeah. So with my class, so initially first wrote it during like prime COVID season. So it was all remote, right? And whenever I wrote it, I kind of wrote in the labs for me to just demo them just like that. And then I was like, well, that's not good for students to have the lab time. So what I ended up doing is saying like, all right, well, I'm going to hang out for like a couple hours after each class and before each class to just answer questions for labs. So yeah, I still do that.
Okay. All right. So, hey, everyone, thank you so much for joining us for this Black Hills Information Security webcast. If you ever need a red team, threat hunt, pen test, you know where to find us. But Beau, you'll be back in the future. You'll do more webcasts. We do webcasts pretty much every single week. So if this was your first time here, we hope you come back and enjoy one of these again.